So we're going to hit a couple of the things in the nearest part of our capital improvement plan for the next 4 years here. I wanted to point out one of the things that maybe wasn't real obvious. Since the 30A construction of the treatment plant, we've had 2 serious upgrades, one in 72, one in 92. We're coming back around where if not for regulation for capacity, we're getting due for another one. The past staff and administration and everything of the plant has been really good at reusing everything that's been put in. There's only 2 small tanks at that plant that I can identify that haven't been reused. And you'll see where these 4 things that are bulleted here, we kind of get into the same trend. We're gonna retask tankage as much as we can to benefit the capacity of the plant to more than, I don't know, double in some cases some of our capacity. So Chris will go through what's coming up in the next few years here.
All right, so now we're going to get into, as Joel said, the future capital improvement plans. I'm going to start off basically looking at our biosolids issues. The dewatering go to a dewatering process. So instead of hauling out a liquid biosolids like we currently do, we would produce a solid product and then put it through a greenhouse along with some added heat to make a dried product in the most green way possible. By doing this, we would hopefully produce a Class A biosolid. Class A biosolids are an exceptional quality biosolid. Basically, we currently produce a Class B biosolid. The only thing really holding us back is our percent solids, which is the moisture capacity, which we'd be solving through solar drying, as well as our fecal coliform counts or pathogen control. And by drying, we should be able to reach that as well. Class A biosolids are a less regulated material than what we currently land apply. So there'd be no need for us to get more land to apply on. This material isn't required to be applied on DNR approved sites. This material would be available for people to come and, or not necessarily the general public, but a farmer or some other end user would be able to come and pick the material up and truck it to wherever they need it, and then use it to their discretion, as just like any other fertilizer. In the process, this would save the utility over $80,000 per year in trucking costs. So that would help offset some of the costs of any projects. So now that we've dewatered the material and turned it into a Class A biosolid, all the water that's coming out of that material still needs to be retreated. And as I said before, the phosphorus that's in that liquid stays in the liquid. So you're pressing out all this water, getting rid of the solids. Well, all that water is going to have to go back through our treatment process again and have all that phosphorus removed again. So what we're looking at doing is installing a nutrient harvesting reactor. The struvite that I had talked about that's causing us problems in our digesters, we're basically taking that same material, magnesium ammonium phosphate, and creating it in a controlled reactor to produce the material in a manageable way rather than in our digesters. This will help us in 2 ways. It'll remove majority of the phosphorus from our solids process, which means we'll get closer to our phosphorus limits, our more stringent phosphorus limits, because we won't have to return as much phosphorus through the system. And it'll also remove a costly maintenance nightmare of the struvite removal. The cool thing for me personally, it takes what is viewed as a pollutant in this area and it turns it into a saleable fertilizer. This magnesium ammonium phosphate is the same stuff that they put in all the manufactured fertilizers. It's just they manufactured in a warehouse or a manufacturing plant rather than a wastewater treatment facility. The next step to our process here is to handle our digestion capacity. We'll be looking at converting a biosolid storage tank to an anaerobic digester. So to over double our digestion capacity. The added detention time will reduce biosolids by destroying more of the solids, and in the process that will increase the amount of biogas that we produce as well. It gives us the opportunity to increase our hauled waste program and the revenue from that program. And with the extra digestion capacity, the utility won't be in the position to limit city growth. Then we're going to be looking at a second biogas system. As I've kind of hit on the entire way here, we currently use 70,000 cubic feet of biogas a day to produce electricity. We currently produce approximately 100,000 cubic feet a day. After the brewery high strength waste project is done, we'll be producing greater than 120,000 cubic feet a day. And after adding the extended detention time of the new digester, we would produce over 140,000 cubic feet a day. This extra fuel will be able to fuel another engine the size or bigger than what we have currently. That's a minimum of 4,320 kilowatt hours per day that we'd be able to push onto the grid. The heat from that unit would be captured and reused to heat the new digester up to the 95 degrees that's required, as well as used as supplemental heat for during the winter for in our greenhouse solar dryer. So as you can see by looking through these plans, the utility has taken a proactive approach, trying to come up with the best available technologies to meet every one of our current issues. They're all very cost effective and hopefully have minimal impact on rates. They address all of our regulatory and capacity issues, and they can be done in a logical step implementation, so they don't all have to be done within 1 year. They can be spread out over a couple of years. Most importantly, these are necessary projects that will not only address the regulatory and capacity issues, but also generate multiple revenue streams as well.